and hi to Dr. Shafar Riniza. Today, we will present about the application of first order differential equation, and we choose to present about Newton's law of cooling. But let me introduce our team member first. First, we have Wan Zulaka Auni. Second, we have Nur Afini Fitra binti Muhammad Ashril, which is myself. Third, we have Intan Karunisa binti Basri. And last, we have Nur Aini Fazlin binti Muhammad Zaki. First, let me introduce what is the Newton's law of cooling. What is Newton's law of cooling? Newton's law of cooling describes the rate at which an exposed body changes temperature through radiation, which is approximately proportional to the difference between the object's temperature and its surroundings, provided the difference is small. What is the Newton's law of cooling formula? Newton's law of cooling formula is given by where T small t is equal to temperature of the body at time t, Ts is equal to temperature of the surrounding, K is equal to positive constant that depends on the area and nature of the surface of the body under consideration. However, Newton's law of cooling has some limitation. First, the difference in temperature between the body and surroundings must be small. The loss of heat from the body should be by radiation only. The major limitation of Newton's law of cooling is that the temperature of the surroundings must remain constant during the cooling of the body.
Now, we look at the problem statement. The problem statement says that an ice cream initially at a temperature of 24 Fahrenheit is left to melt in room with an ambient temperature of 72 Fahrenheit. After 11 minutes, the temperature of an ice cream has gone up to 35 Fahrenheit. According to the Newton's law of cooling, the rate of change of the ice cream temperature is proportional to the difference between its temperature and the ambient temperature. Now that we understand the problem, let's move on to see what we need to find. The key questions are: first, the temperature of an ice cream at any time t. Second, the temperature of an ice cream when t equals to 15 minutes. Third, how much time will it take for an ice cream to attain a temperature of 13 Fahrenheit? Fourth, the time taken t for an ice cream to completely melt. Let's explore how to solve this step by step.
Now, let's solve this problem. In order to solve this problem, we need to find the temperature of an ice cream at any time t by using the Newton law of cooling, where the formula given is provided at this slide, where dt over dt is equal k t minus t surrounding. So let t be the temperature of an ice cream at any time t. Given the temperature of surrounding is 72 Fahrenheit and the temperature at initial is 24 and the temperature at 15 minutes is what we need to find, and the temperature at what minutes where the temperature is at 30 Fahrenheit. Next, we substitute the value of t surrounding 72 into the formula and we get dt over dt equal kt minus 72. Next, we bring the t minus 72 into the left hand side and we get dt over t minus 72 equal to k dt. Then we integrate both sides and we get ln t minus 72 equal to kt plus c. And we solve this, we get t equal to C exponent power of KT plus 72. Next, we can find the value of C. We need to use the information given where the temperature at initial is equal to 24. When T equal to 0, the temperature equal to 24. Then we substitute, we get 24 equal to C exponent power of K times 0 plus 72. Then we solve it, we get C equal to negative 48. We substitute the value of C into the previous equation we get before. Then we get T equal to negative 48 exponent power of KT plus 72. Now, in order to find the value of K, we can use the information given when temperature at 35 Fahrenheit, the time is equal to 11 minutes. So we substitute it into the previous equation where 35 equal to negative 48 exponent power of K times 11 plus 72. Hence, we solve this, we get K equal to negative 0.02366. Then, we substitute the value of K into the previous equation where we get T equal to negative 48 exponent power of negative 0.02366 T plus 72. For the next solution, what is the temperature of an ice cream when T equal to 50 minutes? We substitute the value of T equal to 50 minutes into the previous equation that we get, which is T equal to negative 48 exponent power of negative 0.02366 T plus 72. We substitute, we get T equal to negative 48 exponent power of negative 0.02366 times 50 plus 72. Then we get the value of temperature equal to 57.29 Fahrenheit. That is the value of the temperature of an ice cream when the time taken is 50 minutes.
Okay, now let's dive into understanding how temperature changes over time using this equation for melting ice cream. T equals to negative 48 exponent power of negative 0.02366 T plus 72. On the left, we are calculating how long it takes for the ice cream to reach a temperature of 30 degrees Celsius. First, substitute T equals to 30 into the equation. Rearrange and solve for T. 30 equals to negative 48 exponent power of negative 0.02366 T plus 72. Then simplifies it to T equals to 5.64 minutes. So it takes about 5.64 minutes for the ice cream to warm up to 30 degrees Celsius. Okay, now on the right side, we are determining how long it takes for the ice cream to completely melt. Assuming the ice cream is fully melted when the temperature is nearly equal to the surrounding temperature, we set T equals to 71.9. Again, substitute and solve for T. 71.9 equals to negative 48 exponent power of negative 0.02366 T plus 72. This gives T equals to 260.94 minutes. Okay, so in conclusion, the ice cream reaches 30 degrees Celsius in about 5.64 minutes. It completes the melt in approximately 260.94 minutes. Okay, so for the conclusion, in this case study, we solve our problem using Newton's law of cooling mathematical model, which is d capital T over d small t equals to K in bracket T minus Ts. We can estimate that the ice cream will reach 57.29 degrees Fahrenheit after 50 minutes. Meanwhile, at precisely 260.94 minutes, we can determine that the ice cream will melt. As we may observe and confirm by looking at the solutions to our everyday difficulties, this tactic has been used unwittingly quite a bit in our daily life. People would most likely find it difficult to identify the exact source of their cooling problems without this method. Okay, that's all from me. Thank you.